To this evening's 2021 Art AI Festival online event. I'm Tracy Harwood, the festival director, and in my day job, I'm Professor of Digital Culture at the Institute of Creative Technologies at De Montfort University in Leicester. First, a bit of housekeeping. In tonight's live YouTube stream, you will be able to post comments and questions in the chat area. Chris Tyra, who's the Digital Arts Manager at Phoenix, and I are hosting you in that chat. And we have some great technical support this evening provided by Sean Clark of the Computer Arts Archive and the Computer Arts Society behind the scenes here. And Luba Elliott, our curator, is going to be leading the live show and discussion this evening with you. We will be recording the stream from our Zoom channel, which is where we're at the moment, and also on the YouTube stream, and we'll be posting the event afterwards too. Before I hand you over to Luba, I want to begin by thanking the festival partners for the extensive support we have had from them. First of all, from the university, my university, De Montfort, from Luba Elliott, who's the festival curator, from Phoenix and High Cross, to our funders for their patience and support, and to our technical partners, to the venues, and most importantly, to our artists. Thank you very much. COVID has been devastating to many in the arts and culture sector, and its knock-on impact is felt right across the cityscape. But we've been able to adapt our programme, working with our artists to provide an extended opportunity for local people and for those further away to engage with some amazing creative AI artworks, as well as extend our reach through this online programme. We hope our programme goes some way supporting the cultural infrastructure we all value, but also in exploring new ways we can think about culture and the arts in a technological age. So without further ado, I'll hand you over to Luba, and she will introduce you to this evening's speakers. Thank you very much, Luba.
Thank you, Tracy. So this evening we have two speakers. We have Harshit Agrawal and Alex Mordvintsev. And so these are two artists who are displaying work as part of the festival. And we will start off with Harshit's presentation. And yeah, Harshit created work called Masteriality for the festival, which if you're in Leicester is actually on now. But to give you some more kind of background information about Harshit Agrawal is an AI and new media artist. And through his practice, he explores what he calls the human-machine creativity continuum. So the melding of the human and machine creative agency. And he uses machines and algorithms and often creates them as essential parts of his art processes, embracing becoming the cyborg artist. And he frequently juxtaposes traditional art media and tools along with machines and computation, creating a space to both direct and be guided by the machine. So yeah, now I'll hand over to Harshit, and yeah, we'll listen to his talk. And if you have any questions, please do post them on YouTube, and we'll answer them in kind of the last 15 and 20 minutes. So Harshit, over to you.
Thank you so much, Luba, for that introduction, and definitely thank you, Tracy, Luba, Sean, and everyone who's involved with the festival, all my fellow artists, and for having me a part of this. It's been a really wonderful experience being remotely involved, but still sort of feeling the pulse of the festival. I'll be talking about my art practice with artificial intelligence and how sort of identities or transformation of identities is also sort of a core theme that runs through the works, but I'll be discussing more themes as well across the talk. So broadly, I've been working in this space for a few years now, and a couple of things that sort of guide my work on the whole are this idea of thinking of human-machine creativity as a continuum rather than sort of this disassociated sort of entity where the machine is used to just perform certain visions of the human artist and just bring them out. Rather, it feels almost like this continuum where you are working with the machine as almost a close collaborator to have enough influence on your work through the process of creation. And that really, for me at least, is a new form of thinking of creative expression using machine learning. And the other key theme is also to think about sort of how we can use new technologies to then create work that is a commentary on technology and our existence within it today. And also sort of relook at some aspects of society through the lens of technology, if they can help sort of reform that narratives that used to exist in the society in new, interesting ways. So to that extent, I'll share some artworks over the years, which will sort of try and give some insight into my practice. So one of the first works I want to share is called A Flying Pantograph. These are some still images of that work from Asia Culture Center at Guangzhou from a 2018 exhibition. And this is from another exhibition of that work. The idea with this work is to think of human augmentation, and the idea of thinking of sort of breaking the bounds of physical expression that are limited by the capacities of the body. So here what happens is someone walks up and starts sort of moving a pen on a table, and a drone mimics that motion at a far off remote canvas in real time, sort of binding the two and kind of creating an artwork where the drone acts as almost an infinite extension of the human hand, but also through its sort of motion dynamics brings the artist to a more sort of concentrated cognitive space where they're thinking and responding to the motions of the drone, sort of the little squiggliness and stuff that it adds due to the friction with the canvas and so on. So this began a sort of thinking of that continuum space that I was talking about, and the idea of using technology as a means of augmentation, but that did not have in any sort of modern sense any intelligence in the robot, but definitely work by Alex, who's my co-speaker, and excited to be sharing the session with him, created Google Deep Dream, and this, to my knowledge, sort of really kicked off this modern day AI art kind of a growth of artists around this theme. And I was also, while I was working with sort of these ideas of augmentation and continuum with drones and so on, I was also really fascinated by looking at Deep Dream and the visuals that it created. And one of the early works back in 2015 that I did using Deep Dream as a base is called Tandem, where the idea is, can you draw something as just as a simple sort of paint application, which you have on the left of the screen, but can you now immerse into this continuum with a machine where as you draw something and let's say you hit the imagine button, the machine runs the Deep Dream algorithm iteratively to come up with this imagined version of your input drawing. And it started creating these very fascinating outputs. Obviously, sort of inherent in this is the reflection of the data set having lots of dog species and whatnot. But it still became very interesting to think of, like anyone you would sort of ask what the image on the left looks like. It is probably thought of as leafless trees in sort of a deserted land, but the machine imagines them as these dogs with large ears. And this sort of idea of suddenly expanding the scope of what you yourself would interpret your drawings as became very interesting as an interactive sort of work with the machine. So this is just a video capture of how the system works. So you draw something and then you run the system to sort of in real time almost offer these alternate imaginations of your work. So yeah, this sort of started this journey on thinking about machine learning AI as a not just as a tool to sort of implement, like I said, your creative vision, but also as something that allows you to almost come into a space of partnership where you're working with the machine to sort of collaboratively sort of create the final artwork. Although this tends to raise the question: is the artist the human or the machine? And the artist is the human, but just that evolution of the human artist to allow for that room of influence, I think, is something that we need to sort of think about more deeply. And the other, I think, key technology, and I've sort of continued working with generative adversarial networks for a few years now as the core sort of base of creating art with machine learning, is this GAN technology, which essentially allows you to generate images that correspond to a training set of images that you feed the machine. And then you have various levels of sort of control as an artist to work with this algorithm to direct it or get influenced by it towards creating a final work of art. And just as an analogy, not the most sort of scientific analogy, but a more practical analogy to sort of how art was created earlier, to sort of how probably in an AI world, as an AI artist, I find analogies to that world is sort of the raw material or the paints of the earlier world translate to data sets of today's world, and that itself is a very sort of strong statement that the artist makes as to what data that they choose to work with in the artwork that they're creating. And there's lots of stories in the raw material itself that sort of get communicated through the work. And the way to sort of manipulate that raw material to create the artwork is where paintbrushes were used earlier, sort of to paint with the paints. Nowadays, you use sort of machine learning algorithms to manipulate the data in certain ways, to transform it and ultimately create the final artwork. And I think this sort of approach is quite nicely demonstrated in this artwork that I did over the last year with an artist collective called 64/1, based out of Bangalore, India also, where what we did was essentially collected about 2,300 hand drawings of what people in India think of gender's visual representation. So the cue to the people was to draw a standing female form and a standing male form. Before the lockdown started, we were handing out sort of sheets of paper to people to draw these, and then we eventually sort of did half of the data collection through Amazon Mechanical Turk. So these are some of the representative drawing samples that we collected, and this itself is really sort of beautiful to look at in terms of the variety of how people think of something that otherwise might be considered as probably a universal kind of notion that this is how a standing male form looks like, this or standing female form looks like. So that idea of the art being in the data itself, I think, is very sort of clear from this. And once we had these collections, we trained a GAN system using style GAN to sort of parse these human drawings into machine-generated outputs. And what we also did simultaneously is trained a classifier to take the initial data set collected and train that classifier to sort of classify AI-generated outputs as either male or female with a certain percentage accuracy. And that created ultimately, through the AI generations, this almost the spectrum of gender visual representations as classified as 100% female to sort of 0% female, which we laid out on this circular gradient kind of representation. The final artwork constitutes of this particular imagery that you see on the screen, but also 3 books which sort of talk about data, the male and female data collected, and sort of one that shows these outputs in larger resolutions. We made it a primary objective to sort of ensure variety in terms of, or diversity in terms of, the occupations of people that were submitting the drawings to be from different walks of life of India. So just to think of this from a slightly larger point of view, this using AI as a way to make art from collective representations of things is something that is inherently only possible through machine learning, because that is what allows to sort of process these large amounts of data. So just this sort of philosophical debate of do universals exist or not, there's probably some practical approach to thinking of that concept, like a million people have tagged an image as black or white or something. So probably that's sort of that universal notion of what a certain concept means. Like, for example, here we took that approach for gender representation, visual gender representation. So moving on from that theme to also thinking of if you're collectively able to take some concept and create work from that, there's also the idea of, can we take some concepts that have existed and use AI or technology as a means to probably transform the notions of that societal concept, for example. So that's where sort of this Masteriality work, which is part of the exhibition, the festival, RTI festival, is that is where this idea is born. Sort of, can machine learning help to sort of think about our identities and traditional cultures from a completely new vantage point? And in general, I've been fascinated by mass cultures, and they've probably existed across cultures for thousands of years as a means to engage with the world from completely different sort of identities, and suddenly transform yourself into, or transcend almost into, something that you're not. And AI or machine learning also kind of has that capability to sort of push human sort of human embodiments or ways of thinking of human into completely different realms. So I started exploring mass cultures of India, and was very fascinated by this 2 particular sort of dance rituals of southern India called Thayyam and Kathakali, which both belong to the same state called Kerala, the southernmost state of India. And they have these very beautiful, like, face painting rituals as part of the dance performance, and these very elaborate headgears and costumes and whatnot. And there's also something very interesting from a societal perspective of these dance forms, is that Thayyam was traditionally performed by tribal population, or the low caste sort of population of India, and Kathakali by higher caste and the Brahmins, which is sort of the highest caste people of India. And for Kathakali, like, no one from the other caste was allowed to even enter the place of performance. And Thayyam was very sort of in the open, rural kind of settings. And that existed as a form of discrimination for a long time. And that is something that sort of Masteriality also comments on, that what happens with Masteriality is an audience stands in front of a screen, and through a webcam, their face outlines are read, not captured or stored anywhere, but just read for that moment. And there is an AI system that is trained to convert those face outlines into Thayyam and Kathakali face paintings simultaneously. So what happens essentially is as an audience, become both a Thayyam and a Kathakali performer together simultaneously, which wasn't possible because of the caste discriminations earlier. So it's almost this comment on breaking through technological transformation, this sort of idea of what your caste allows you to do or not in society, and also transforming your identity along the lines of viewing yourself both as a male and a female form simultaneously, to then start sort of beginning to reflect on again that sort of breakage of binaries, or confusing those binaries to a large extent. So just sort of this, you stand in front of it, you become the artwork, and that the attempt is to try and get you engaged to it enough so that you start sort of reflecting on these aspects of identity and the politics and the history of identity in some sense. And there's also, with Masteriality, there's also static works in the series where I work with masks and generate these 2D images. And there's new work starting this year that I'm doing, which is called Masked Identities, where along with sort of masks as a data set for GANs to work with, I'm also adding human figures, which essentially result in this sort of part human, part mask kind of outputs. And very quickly, sort of the last project I want to share is more about commentary on tech and our existence with it through a piece called Authorized, where what happens essentially is a person starts writing something, and then control of their hand is taken over by the machine to continue writing. So they just hold the pen and the machine moves their hand to continue writing the machine's thoughts on the piece of paper, using the human almost as a mechanical arm. And how the system works is sort of, there is a magnetic plotter under the table, a plotter with a magnet that attracts the tip of the pen. And based on what you've written, or you may choose not to write anything, the system generates some text from being trained on philosophy books, and then sort of converts that text to handwriting and moves the magnet to then control your hand to write something. Sort of outputs like this, where the person wrote freedom of man and the machine wrote as a myth, who is a moral and a nice person of the state to say the truth. So just sort of this weird back and forth, but this idea of losing sort of control in something very subjective like writing a piece of paper, and then the idea of questioning where authorship in our everyday tasks with machine learning devices starts and ends. So that's all I have for today. Thank you very much. I'll stop sharing my screen.
Thank you, Harshit, for the wonderful presentation. It was really good to hear all about kind of the spectrum of your work and all the different projects that you've done. And yeah, so now we can move on to our second talk of the day by Alex Mordvintsev. So Alex is an artist and a researcher working with AI and artificial life. In 2015, he invented the deep dream algorithm, which you also might have seen was kind of mentioned a little bit in Harshit's presentation. And yeah, with Deep Dream, he launched an entirely new subgenre of art using neural networks and transforming the way we visualize them. He is currently working on self-organizing systems, exploring practical ways of designing artificial life through machine learning. So yeah, over to you, Alex.
Hello, thank you. Thank you, Luba. Thank you, Harshit, for a wonderful presentation. And thank you all other festival organizers for selecting my artwork and for giving me the opportunity to present. I've prepared a little video, and now I'll try to play it through Zoom. Hope the quality wouldn't degrade too much. And first in this video, I'll talk about like deep dream, creation of deep dream. Then I'll proceed to my later neural network visualization and artistic experiments. And finally, I'll talk about differentiable self-organization and neural cell automata. So let's try. So deep dream. I joined Google in the year 2014. Where I got into one of the few teams that started adopting recent deep neural networks to production tasks. And I got surprised by what they could do. I mean, I had some computer vision background, and I thought I have a pretty clear idea of what's possible and what's not with computers. And those things were definitely exceeding my expectations. So I decided that I have to figure out how do they work. To my surprise, there were already hundreds of papers that were adopting yet another neural network architecture to yet another problem or data set, but very, very few that were really trying to look under the hood and figure out what's going on. One of the papers that inspired my research is called Deep Inside Convolutional Neural Networks. In one of the experiments, authors were using input image optimization to produce class visualizations by pre-trained neural network. The resulting patterns looked very promising to me. Another source of inspiration was the paper that introduced the concept of adversarial examples, imperceivable image modifications that fool the neural network. In this video, I'm trying to visualize the basic idea behind deep dream, which can be formulated as whatever you see in this image, I want more of it. Deep dream was one of many experiments we tried to understand what's going on inside deep neural networks. For example, we noticed that maximizing activations of individual neurons of a pre-trained network reveals the world of patterns that resemble parts of objects that the network was trained to classify. We published our findings in the interactive article that's called Feature Visualizations. Around that time, my wife convinced me that the research I do can also be treated as art. Together, we started doing prints, exhibitions, and artistic collaborations. For example, this is one of my favorite videos that was made together with our friend musicians from St. Petersburg. In another article that's called Differentiable Image Parameterizations, we explored ways of representing images for image generation through backpropagating to the neural network input. We studied decorrelated spectral representations of images, compositional pattern producing networks that are essentially tiny neural networks that map point coordinates into pixel colors and have some attractive properties like infinite resolution of resulting images. We also experimented with generating objects that lie beyond the domain of RGB 2D images, for example, images that have alpha masks or coherent textures for the 3D models that may have very fragmented UV parameterizations, such as those that are coming from photogrammetry. To achieve this, we employed differentiable rendering, which happens to be a very hot topic in computer graphics right now. We put a lot of effort into making sure that our results are easily reproducible within just a few minutes using Google Colab notebooks. Unfortunately, during working on this video, I realized that some of the notebooks happen to be broken because of the changing dependencies. I'm going to fix those notebooks soon, but this event made me want to include another recent project into this presentation. It's called DeepDream.c. I made it to celebrate the 6th anniversary of rendering the first Deep Dream images. It's also a response to increasing fragility and complexity of modern software. It implements neural network inference, adversarial example generation, and pattern hallucination with less than 900 lines of C code. I'm only using technologies that are available starting from the 80s years of the last century, but are still widely used today. std.io is the only library header it includes. Now I would like to talk about my most recent effort, Self-Organizing Systems project. The Hexells demo that was included into the SIGGRAPH art exhibition was a part of it. Self-organizing systems consist of a large number of locally interacting agents that work together towards some shared global goal. Such systems can be observed everywhere in nature, from microscopic to global scales. Those systems are highly robust and adaptive, to the degree that's unmatched by current human technology. This project was mainly inspired by a presentation called What Bodies Think About that Professor Michael Levin gave at NeurIPS 2018. Watching this presentation, I realized that some of the amazing properties of living systems can be modeled by using differentiable programming that also powers the current generation of deep neural networks. We refer to this idea as differentiable self-organization. Generally speaking, differentiable self-organizing system consists of a neural controller that is shared by a population of agents interacting in a simulated environment during the limited time span. The whole system is evaluated against an objective function that measures the similarity between current system behavior and the desired. End-to-end differentiability allows propagation of the gradient towards the neural controller, steering the system behavior towards the target specification. We implemented this principle in a neural cell automata model, or neural CA. Neural CA operates on a uniform grid, where the state of each cell is represented by a number of real values, 3 of which are visible as RGB color channels. Cells iteratively update their states using the information collected from their 3x3 neighborhoods. Cell perception is also affected by the local orientation vector. Smooth manipulation of those vectors allow projection of the resulting patterns into arbitrary rotated vector fields. In our first experiment, we trained a number of cell automata model to grow and persist predefined patterns starting from a single seed cell, trying to mimic the development and regeneration of a multicellular organism. Interactive demo that accompanies the article allows readers to play with the resulting models and put them into situations not seen during training. In another line of experiments, we employ VGG-based perceptual texture loss or inception-based feature visualization losses to train cell automata models that synthesize textures rather than pixel-perfect patterns. Interestingly, we don't enforce stability of the produced textures, so our method accidentally turns static targets to life. Regular structures tend to produce particularly interesting behaviors, trying to build global order from local interactions only. In our distilled publication, we explore various interesting properties of cell automata models, such as their ability to operate on grids that have different structure than used during training, or capability to synchronize and produce coherent patterns even when parts of the grid updated with substantially different traits. The capability of neural CAs to operate in out-of-training situations is pretty spectacular. For example, we observed the capability of 2 different cell automatas to coexist and cooperate on the same grid in case they share a common ancestor checkpoint or one is fine-tuned version of another. This enables interactive painting with living brushes that were independently trained to synthesize different textures. Capabilities of neural cell automata span beyond image generation. For example, in this experiment we trained a neural CA to recognize and miss digits. Pixels that constitute digit must talk to their neighbors to figure out their global shape. They should also be ready to reconsider their decision in case pattern changes. It's also possible to train an adversarial rule that will steer the system into wrong decision. System generally manages to recover into correct state after removing the adversarial cells. Interestingly, additional restrictions make self-organizing systems even more robust. Adjacent grid locations of the model you see here can only communicate through isotropic diffusion of their state vectors. So the resulting system becomes a variant of a classical reaction diffusion model, where only the reaction term can be trained by optimization. It's now a space-time continuous system of PDEs that's invariant to grid resolution and orientation. They can be applied to arbitrary manifolds that have a diffusion operation. Models trained in 2 dimensions even generalize to higher dimensional space. Narrow cell automata models can be surprisingly compact. For example, the behavior you see here is described by just 588 parameters and easily fits into a shader. Such simple models can be potentially implemented as tiny electronic circuits. We are also constantly looking for new problems and models to apply the principles of differentiable self-organization. Okay, so thanks for watching, and I hope this presentation wasn't too technical, and I'd like to add a couple of words from the higher level perspective, like what's the motivation of doing all of this. And this motivation is like whenever you see, I see a living thing, like, you know, trees that grow outside of my window, or grass. I see how well, or even parts of myself. I think how much more sophisticated living things are than the technologies that we are building. And especially it's kind of whenever I hear about some huge infrastructure project that is being carried out, especially if it's more of, you know, well, something that claims to be the highest ever, the biggest ever, I always see, I try to imagine, like, for how many years will it serve as a as a something functional, and then for how many years will it be acting as a ruin. So and this ruin state is much more persistent, like as something as, you know, Soviet era mega structures that got abandoned. And this is so different with the way nature built things, starting small, not planning to be big, and then things become big only when it's needed or when it's possible, and when it makes sense. And that's why I'm always thinking, is there, say, ways to build infrastructure that repairs itself, support itself, and grows when more capacity is needed, shrinks down and decays only when it gets abandoned and used and becomes parts of the landscape or something. So this is what motivates this line of research in self-organization. And I'm ready to take questions, and thank you for your attention again.
Thank you so much, Alex, for the wonderful talk. It's been, yeah, really good to hear about Deep Dream and like the types of things you're working on now. And yeah, I've noticed from the chat that there's quite a few questions for you both. Yes, I think we'll start off with one for Harshit from Gemma Hewitt. If you feel your work with AI could be described as collaborative, or if working with an AI is like using a tool that enables surprising results?
Sure, yeah, thank you for that wonderful question. So I think, like I was trying to sort of mention through the talk, that AI or creating art with AI definitely goes beyond the the traditional thinking of a tool which is used to just implement completely an artist's vision and bring that to sort of life. I do feel that I mean, AI could be used in that sort of limited capacity, but I do think as an artist, the exciting aspect is to sort of use it beyond that capacity, in a sense where you're accepting that there is that sort of sweet spot for influence by the AI onto what you've started creating. Ultimately, like I mentioned, this could get confused with sort of is the art created by the human or not, or is the artist the human at the end of the day? The artist still remains the human person, because the ultimate choice of what they choose to call the artwork or what starts to drive the artwork is very much in the realm of the human. But as an artist, as an AI artist, I do look at it sort of beyond just a tool to just fulfill my vision in some sense. Yeah.
Mm-hmm. Yeah, sure, makes sense. And now a question for Alex from Ben Bogart, actually another artist who will be participating in our festival. So Alex, could you tell the story of where the names Deep Dream and Inceptionism come from?
Okay. Yes, the story goes in the following way. First, I created this little program that produced strange hallucinations as a failed image super resolution experiment and shared it inside of Google. And the original name was Deep Sea, actually, because, well, deep, and then I think we wanted to go to the sea, and sea played like sea as a sea, played with the word sea like sea with eyes. So that was the original name. And then when we decided to eventually, well, hundreds of people inside of Google started playing with it, and some images started leaking outside. So we decided, so we should rush and publish it. Somehow, so we released this blog post that's called Inceptionism. Well, this is just one of the names that we came up with. And then the author, because of the original neural network that we were using, I was using pre-trained Inception neural network developed by Kristen Segedi. And then Kristen Segedi told that, I'm a little bit unhappy without this name because I'm getting the questions regarding the work I'm not involved with. So then we decided to, when we were open sourcing the code finally, we just had a little brainstorm, wrote down like, I don't know, 5 to 10 names and just selected one of them. That's pretty much the story. And Luba, if you allow, I see another question in the chat that's called, did the separation of input into content and style come from the knowledge of art, or was it a very technical decision? And I'd like to tell that, first of all, there is a great confusion about what people call the dream, because what the question refers to is actually originally a neural algorithm for artistic style transfer that was developed by a different group and published a few weeks after we published Deep Dream. So this algorithm relies on using very, very closely related approaches. They also do backpropagation to the neural network input, trying to maximize some objective function that is defined in terms of internal neural state of a neural network. So, and given how related techniques are, basically, when we published the code, so where third-party services started, like Deep Dream generators started to pop up over the net, and then when they published their work, those services were very quick to adopt their approach, their fantastic, very interesting work. And this confusion between what people called Deep Dream and style transfer is still still exists. And for style transfer, I guess for people who did that work, I'll try to follow their line of thought. But first they started with text to synthesize. So, and then they came up with style loss. And well, I guess at some point they started thinking of artistic applications of their text to synthesize algorithm, and came up with that idea that you can actually style image, like do this separation. But the actual authors, the name of the paper is, if you allow, let me just share a window. Once I've read it, so that's the name of the paper, and these are the original authors of the technique. Okay.
Thank you, Alex. And yeah, another question for Harshit, or actually perhaps for you both. How easy or difficult is the art and AI curriculum? What age group can be trained? So I guess if people are keen to like begin working or playing with AI, yeah, what are maybe some tips or resources that you'd share with them?
I could quickly sort of answer a little bit from my experience. So I've actually had the experience of taking workshops around AI and creative AI with different age groups of people, ranging from middle to high schoolers, which is grade 8 to 12 in India, which translates to roughly, let's say, 14 to 18-year-old people. What has been very helpful is definitely there are very interesting tools out there, like the one by Google, Teachable Machines by Google, for example, which really sort of makes it easy to have very quickly an interactive demonstration of machine learning. You drop in some images, or you, as a classroom, sort of record sounds, etc. So it just gives you the instant sort of understanding of what's happening, your data being trained, and then responding to further inputs as to classify those or something like that. And then also sort of one step ahead is something like Runway ML, which is again a very user-friendly sort of system where you can essentially run a lot of these AI algorithms like GANs, etc., on your data sets to sort of start getting hooked to the idea of immediately beginning to create something, and then that becoming a means to sort of delve deeper into. Then sort of the next progression is probably sort of Google Colab notebooks, like something that Alex mentioned, where there's code available that you can sort of run sort of notebooks and hit each of those cells and maybe start understanding what's happening. And yeah, the math of it and etc. is slightly convoluted, but there is sort of ways of getting into it and then sort of going deeper and deeper, which is very exciting. Yeah.
Okay, thank you, Harshit. And yeah, so Ben Bogart has posed another interesting question for you both. What happens to art when art is made by engineers or scientists who don't have art training? Does art become design? Does the label art even matter in creative tech? What do you think?
Okay, may I try to reply? So to me, after we published the brief for a couple more years, I've never, like, I didn't consider myself as an artist, and it's actually under the influence of my wife, who told me, no, you're doing art. So first of all, the question of how many of the famous influential artists who shifted the paradigm had formal artist training. I don't know, but I'm not sure that all of them were officially artists with diploma that says that they're artists. And also this question is what's art and what's not art, what's science. I guess my the best take that I managed to come up on that is, well, as long as you like when you are doing art, you are not obliged to cite your sources, and you don't have to explain the trick. And then when you're doing science, you have to cite sources, explain the trick, and also you have to prove that the work that you are doing is sufficiently similar to what people have done before you, so that so that you get treated seriously. And there are very, very many cases when breakthroughs where like breakthrough research was abandoned because no one just realized that, yes, this is something that will change the paradigm, that will be tremendously impactful. And there are cases when it was delayed, I don't know, 30, 40, 50 years until ideas got caught up. And then it also, I see, like, I follow a lot of great artists on Twitter, and I see that sometimes they are doing, like, in terms of self-organizing systems, they're like tinkering, probing things without even like maybe taking care about the things they do are like, basically they are probably the first people who do it, and there are like these ideas will be tremendously impactful further, but they don't even document them properly. So that's my take on this: what's art, what's science, what's not art.
Yeah, I could very quickly, I think that's a great answer by Alex, and a very sort of practical definition of that separation of citing sources and building on previous work, etc. I also just want to quickly add, I think that boundary is blurring between the sciences and the arts, and or probably has always been blurry. And I think the motivation that Alex mentioned for his work, I found that very fascinating in terms of this trying to understand things outside sort of nature in that sense, and then sort of also connecting that to how societies form structures, etc. And using that probably as a means of, I don't know if that is part of the motivation, but also then using that as a means to comment on how humans have sort of created destructive systems, rather than, like Alex mentioned, that the things grow bigger only when needed, and stuff like that. So I think that sort of continuum between where science, you use scientific inquiry to understand a particular subject, but then also once you've understood it enough, you're able to use it to create commentary on how things exist outside of that scientific boundary. I think that's where that whole science to art spectrum feels interesting to me.
Thank you both for the very kind of interesting answers. And yeah, I think I'll ask just two more questions. In what ways is AI influencing how artists work, and what are the implications for the resources and skills training they need as creative practitioners?
I could begin answering that. I think there's definitely been, at least from personal experience, there's been this influence of the ability to create new kinds of art, particularly like through the project, say Strange Genders, or even the Mask works. Just this idea of creating art with a collective understanding of stuff rather than an individualistic understanding. So almost as a mirror to society in some sense, if I could use that phrase. So that is definitely enabled only through something like machine learning AI. So that kind of influence is definitely there. The influence of almost actually living kind of this cyborg sense of reality, where you are agreeing to sort of let the machine influence your work for part of the creative process. So I think those kinds of influences are very interesting to deeply try and embody, and even through like artists like Sugwen, for example, working with her robots and things like that. So I think that is beginning to influence artists in a very strong way. This sort of shared space with working with the machine. And in terms of resources and skills, there's definitely, I think, a new kind of tool set or sort of a skill set that the artist has to develop for this, so that they're able to understand the systems enough to be actually to sort of meld them in their own ways or mold them in their own ways. But yeah, that's, I think, the part of the excitement of the process.
Well, I may quickly try to add a little bit. So in my particular work, I don't call what I'm doing AI, and I prefer term a life, like artificial life. Just well, because you know, the term AI is somewhat vaguely defined and overloaded, and there is a lot of like this discussion what's AI and what's not AI. And to be honest, I prefer to avoid using it altogether. But what I do notice that, well, those systems, deep neural networks, differential trained system, basically when they are big enough, they start to surprise. And there is a lot of this surprise that system does something I didn't expect it to do. And this was Deep Dream, this was Taskmaster, this was all those GAN transitions, this was a lot of like recent large text neural language processing models do amazing things. And but in my practice, I'm like trying to go in directly opposite directions. I'm trying to make systems as small as possible, as simple as possible. Like, you know, OpenAI trains how many, I don't know, billions of parameters. I work with hundreds of parameters. But that's the collective interaction that I'm getting my own sense of surprise from. But I can't call this intelligence. Maybe this optimization process that managed to find behaviors that do something that I didn't expect system that simple to be doing is a kind of intelligence. But in that sense, intelligence is just optimization, which I don't think is true.
Okay, thank you so much both. So I think we're actually running out of time, and it is time for us to wrap up. Yeah, so thank you so much, Alex and Harshit, for your wonderful presentations and the discussion. I think, yeah, we had some really, really interesting questions from the audience. We're very pleased about the discussion. And yeah, at this point, I'll hand you over to Tracy, who will wrap up. Thank you.
Thanks very much. Thanks very much for that, Luba. Well, very inspirational talks from our speakers this evening, Harshit and Alex. And Harshit's work, Masteriality, you can see currently on display in the Haymarket Shopping Centre. So if you're in Leicester, I do encourage you to go and have a look at it. It's absolutely amazing to be there with these two other faces, these masks that are you but not you, interacting with you. It's a really interesting artwork. And so finally, just thanks very much to our sponsors again, and to our supporters, and in particular to our technical whiz behind the scenes this evening, that's Sean Clark of the Computer Arts Archive and the Computer Arts Society. Thanks, Sean. And to our hosts, Luba, for posing such great questions to our speakers, and also to Chris, who's in the chat on the YouTube channel with you. I think he's been a little bit quiet this evening, not normally that quiet, but there were some great questions coming through from everybody there. So thank you very much to everybody for participating. Finally, you can get in touch with us through any of our social channels and our email, details of which will be posted on the YouTube profile, or you can just click on our profile and follow those links, if you like, and get in touch with us. We'll follow up this evening's event with a request for some feedback. If you wouldn't mind giving some feedback, that would be great. And we'll provide a link to that and also the recording of the stream later on. And from this evening's activities and tonight's live stream event, well, that's basically it from us. So hope you enjoyed it. Thanks again to everyone for turning up, and hopefully we'll see you again at the next event, which actually is on Monday evening. And we'll post some links about that as well, and look forward to seeing you then. Thanks very much, and bye for now.